Mock exams aren't far away, so let's try a question a day. We've got a particle moving along a straight line with velocity equals 16 minus 3t squared. So this is a variable acceleration question because we can see the time is changing. Okay, t squared can change, which means the velocity can change with the time. Okay, so if we look at the distance, well, we know to go from, if we use this, to go from acceleration, velocity, and to displacement, we need to integrate. So acceleration, to get the velocity, we need to integrate. To get the displacement, we need to integrate. If we have s, we need to differentiate. So we're going to integrate v with respect to t, and that will give me 16t minus t cubed, and then plus c. But we know that the distance traveled in the first second will be 1 and to 0, so I don't need this constant of integration because it now becomes a definite integral. Okay, and 16t minus t cubed, substitute 1 and 0, and you get a total distance of 15 meters. Now, the value of t where it changes direction, well, that's just when v is equal to 0. Okay, so all that's happening there, the velocity is equal to 0. So all that's happening there would be 3t squared. Apologies. It will be, so part B, 3t squared equals 16. So 16 over 3 equals t squared. So t equals the square root of 16 over 3. And of course, we are only taking the positive solution to this. Okay? And the reason why it's equal to 0 is because the velocity will then equal 0 and then it will change sign. So in this case, let's say it was positive, it would change sign and go negative, or it would be negative, change sign and go positive. Okay, but it needs to equal 0 first. Now part C, the instant it returns to its starting point, okay, so we're gonna look at the displacement now, and we got 16t minus t cubed. And that will be when the displacement is equal to 0. That's when it will return back to its starting point. So there'll be two times at which this happens. T minus 16 minus t squared. T equals 0. Okay, so that's when it first didn't move off. T equals 0. That's one solution. And t is also equal to 4. And that's the second time where the displacement is equal to 0. So therefore, that's when it has returned back to its starting point. Okay. So I think this was a really good question, okay? Really testing a lot of skills. So I hope you enjoyed the video, and I hope it makes sense. Right, I'll see you in the next video. Take care.